ladder friction. So in the previous classes we have discussed about the block friction and wedge friction. So to start, we'll start with ladder friction. So most of you know that what do you mean by ladder. A ladder is used to climb the roofs or walls. It consists of two long upright wood uprights made up of wood, steel or iron pieces connected by a number of cross pieces. The friction developed between the contact surface of ladder and floor. Also a friction will be developed between ladder and the wall. So here a frictional force will be developed here and this point. So this is the frictional force. And so now let us consider a ladder of AB which is leaning against a wall and on the surface. Now as the upper end of the ladder tends to slip downwards, a force of friction develops between the ladder and the wall. So as the ladder tries to go down, the frictional force will be upwards. So this is FW what I have taken. Next, similarly, the lower end of the ladder tends to slip away from the wall. So this point tries to go towards this side. So therefore friction force will be towards the wall, it will be there. So now if you analyze this here, apart from these weights, you'll have the weight of this ladder, and you'll have also, if the man is climbing, means the weight of the man also will be there, and this is the angle between the ladder and the horizontal surface. So when you take out the figures, so usually we'll have this force system will be a non-concurrent force system will be there. So therefore when we have non-concurrent force system, so you have to use three equilibrium equations, that is summation of h equals 0, summation of v is equal to 0, and summation of moment about any point should be equal to 0. So these are the equilibrium equations you have to consider to solve. Now one more thing I want to tell you is, when you are solving about block friction or wedge friction, there the frictional force, it is actually increasing your efforts actually, because due to friction you have to apply more loads and all. But now in ladder friction, when you have a frictional force will be there. So if you ladder friction, if the friction is not there, means usually the ladder will slips easily. So therefore your effort to stop that ladder will move more. But if you have same frictional force, the ladder doesn't slips. So if you take an example, if you are climbing on a ladder on a smooth surfaces, usually ladder will slips early. But if the same thing, if it is there on the rough wall, and if it is there on the rough floor, it doesn't slips. So these are the things you should be keep in mind, and these are the engineering advantages of frictional of ladder. Okay, so let us solve the problem. A ladder of 5 meter long rests on a horizontal ground and leans against a smooth wall at an angle 70 degrees with the horizontal as shown in the figure. The weight of the ladder is given as 900 Newton, and the man weighing 750 Newton stands on the ladder at 1.5 meter from the bottom of the ladder. So you have to calculate the coefficient of friction between the ladder and the ground. You have to calculate. So this is the figure given. So length of the ladder means the inclined length you have to take it, and it makes an angle 70 degrees with respect to horizontal. Okay, so these are the things given in the figure. So now when you take these things, now so here is the ladder, and here the weight of the ladder is 900 Newton. So remember, always the weight of the ladder should be at the midpoint. So if the length of the ladder is 5 meter, at 2.5 meter the weight should be there. So that is 900 Newton downward should be there, and a man weighing 750 Newton stands at 1.5 meter. 1.5 meter means from bottom it is given. So 1.5 meter from the bottom you have to take it, 750 Newton. So due to the weight of the ladder and weight of the man, so the ladder wants to slip away from the wall. So therefore you will have a frictional force. See here, a frictional force FF, that is frictional force at floor level, FF is taken. So since the ladder goes to the left side, the friction force will be there at the right side. Okay, and here and normal force also will be there, that is normal force at the floor level, that is NF is taken. And here NW is there, that is normal force at the wall is there. And why FW is not there, means that is the frictional force at the wall, because here it is mentioned clearly that wall is smooth. So when wall is smooth, FW should take it as 0. Okay, because mu will be 0. When mu will be 0, automatically it becomes Fw becomes 0. So if you try to analyze this, so some of the small calculations you have to do it. So this is 900 Newton. The horizontal component of this 900 distance is from A point is 2.5 cos 70. So if you take cos 70, it is adjacent this distance divided by 2.5. Therefore, if you want this distance, so this is 2.5 cos 70. Similarly, this distance is 1.5 cos 70. And similarly, this distance, the vertical distance between A and B is 5 sin 70 you will get, and horizontal distance between AB is, you will get 5 cos 70 you will get. That is distance between this point is 5 cos 70. So now if you solve this, this is 5 cos 70, and if you solve this, see, this is the equilibrium of forces. So how many forces are there? 1, 2, 3 forces are there. So you have to find out mu between that is mu at floor level you have to find out. So now to find out that, so let mu f is the coefficient of friction between the ladder and the floor or ground. We'll take it. So now if you take summation of V is equals to 0, if you take summation of V is equals to 0 means sum of vertical forces. So NF is going up, so positive, minus 750 minus 900 is equals to 0. So then for you will get NF is equals to 1650 Newton you will get. So therefore FF, that is frictional force, is given by mu F into NF. Mu is the friction force, mu F into NF. So therefore FF you will get it as 1650 mu F you will get it. Next, if you take moment about B, therefore we see here we have to find out mu, right? So mu will be there at this point. So therefore if you take moment about A, you won't get anything. So therefore you have to take mu f. So if you take at this, so what you will get, moment about B means you are taking moment about this point. So moment about B means first NF, this NF into, that is NF will be there here. So this is the distance. NF into this distance is 5 cos 70, and it produces clockwise moment, so therefore positive. Next FF, this force into this distance, that is FF 5 sin 70, this angle, the distance is 5 sin 70, and it produces anti-clockwise, so therefore negative. Next, this 750 into this distance, that distance is, see, if this is 1.5 means this distance will be 3.5, so that is 3.5 cos 70 you should take it. So so this is 1 point, this is 3.5 cos 70, that is also anti-clockwise. Next 900, this is also anti-clockwise, minus 900 into, if this is 2.5 cos 70 means this distance will be 2.5 cos 70, so therefore 900 cos 70. So therefore in this if you substitute, NF as 1650 and FF is 1650 mu f. So in this whole equation mu f is the unknown, so mu f is 0.149. So this is how you have to calculate. Thank you.